Hi everybody, welcome to this live stream on refrigeration, pressure and safety. My name is Anders. With me today I have our two experts, Niels Vestergaard. Niels is a global application expert and has more than 39 years of experience within refrigeration. Also with me today I have Alejandro Figueira Lopez. Alejandro is responsible for the product strategy and portfolio development of safety devices. We are live on multiple channels across the globe today, so we have chat moderators to stand by and help you guys with your chat with you, and they will funnel the questions into us to us, so we make sure we get all your questions. Yeah, and regarding questions, we want this to be a conversation more than a presentation. So if you have any questions, just fire away, and we will do our best to answer them as we go along. So don't wait to the end with your questions. So just fire away. Yeah, and finally, I just want to say before we start that we have a short survey. You can find the link in the chat. And then you can look at it afterwards or when it suits you. But there's a few questions, and of course that is for us to allow us to become better at this as we try this several times. So, but I won't take much more of our time, and I will hand the word over to our experts, Niels and Alejandro. And yeah, I'll just say enjoy and fire away with your questions when you get them. Thank you.
Thank you, Anders. Hi, everyone. Thanks for joining our chat here. Today, we're going to be talking, a very relevant topic when it comes to, to refrigeration, which is safety and safety related to pressure. Yeah. As we all know, and especially nowadays, with a very increasing trend, which is very good. Safety, it's a very relevant topic, and that is because it is extremely important. When we are talking, about equipment, and in this case, pressure equipment, it is critical that we make sure that our designs, our operations, and the way that we do things take care of protecting people, protecting equipment, protecting our facilities, our production, and to guarantee that we have all in all, a safe operation. Through history, if we look back on different type of equipments and different type of installations, we'll see that there have been many changes driven by, in some cases, some unfortunate stories that have led to regulations that have been improving with the time, and that with the help of people that are really good experts. This has been developing and improving to have better safety standards and better practices standardized up to, let's say, a regional level, and of course at some point we would like that is somewhere globally, so we can guarantee that regardless of where installations are, they follow similar or equivalent standards, and in that way our equipment, our installations, our operations are guaranteed to be safe from the known risk that we have already identified, and that there is already a way to approach those. And in order to start that talk and to talk a little bit on the history of of safety related to pressure, we have a case that was sort of a big change, or one of the things that make put a lot of attention to safety when it comes to pressure. And here I'm going to pass the word to Niels to talk a little bit on this case. Here on the slide you can see some old pictures from this case. Niels, I don't know if you want to take over on this on this story from a couple hundred years ago. Yeah.
Yes, thank you very much, Alejandro. Yes, as Alejandro mentioned, safety is not something new. And this case here that we have chosen to show you, that is actually from back from 1865. And this was a very big accident in the US on a riverboat sailing at the Mississippi River. And it is actually mentioned that this was the biggest accident, marine accident happening in the US. This was not a refrigerant system, but it was a pressurized system that failed. On board this riverboat, there were 4 steam boilers to run the boats. But on exactly the day where this happened, everything went wrong with the boats. This boat was designed to transport 376 passengers. But the matter of fact was that exactly this day, a lot of people had to be on this boat. There was a lot of paroled prisoners, as prisoners from the war, which has been released, and that was 1,960 of these prisoners on board the ship. So actually, the boat, there was 2,137 people on board, almost 6 times as many people as this boat was built to. So there was a lot of pressure on the manshaft that the boat should be sailing, but they had some problem with the steam boiler. But it has to sail because everyone was on board, and so they made we can say, a quick repair on this steam boiler, and then the boat started. But unfortunately, it went into a catastrophe because they had to, we can fire up because it was very much overloaded, and then suddenly this steam boiler exploded and make a big hole in the ship, and then it turns out then the next boiler exploded, and the third boiler exploded, and then the ship went down, and 1,186 people died on that event. So that was and is really a catastrophe. This accident, that was really something that changed, we can say, the focus on safety. And after that, the regulation for pressure equipment has changed a lot over the years and has been extended and improved. So that is for pressurized system, and a refrigerant system is exactly also a pressurized system.
Nils, I'm just going to interrupt you here with a question here from from the audience here, who asked, is a water-cooled chiller considered to be a pressure vessel?
Yes, it is by definition a pressure vessel, so it should be treated in the same way. So everything that you have under pressure is more or less a pressure vessel. So yes, and but I think what is the most important thing here is that if you have such a vessel, you need to have that protected. You need to have safety valves on, and that is what we are going to look into in this session today.
Okay, and I just want to say hello to everyone. I've just listed a few of the countries where you're coming in from, and Dubai, Bahrain, Nigeria, India, Malaysia, United Kingdom, Italy, Philippines, and France, and sorry if I missed anyone, but it's so great to have you here. USA, I can also see you up early. It's so nice to have everybody here, and yeah, just keep the questions coming. Thanks.
Okay. So looking into safety for a refrigerant system, over the years, these requirements has been improved, and also during the last 10 and 15 years, we have seen a lot of improvements. And we will take a look into these requirements. One of the things that you can say is extremely important, that when we make a design, we define a maximum working pressure that this equipment has to be or can be used for. And this maximum working pressure must never be exceeded under normal operation. But however, you can say if in the event that everything failed, we can increase the pressure above the maximum working pressure with up with 10%, but we will take a look into that in a minute. But here to give you a view of, we can say, the requirements for safety valves. If we take the base from the European region, that we have this pressure equipment directive, which states what is the requirements for pressure equipment directive, but it's a very general set of rules or laws in the member states. Particularly for the refrigeration industry, we have a set of standards in Europe. It is EN 378 series, which consists of 4 standards, and in particular, part 2 put up a lot of requirements for safety equipment. If we in parallel take, we can say, the national standard here, then this EN standard has been transferred into an ISO standard with more or less the same content. So the standard is a global standard, but it's not implemented in all countries. Some of the countries where it is used in the same way as we have the European standard, that is in Australia and New Zealand, but there are also other countries. And then it is referring to, of course, the national standards in these regions. Globally, the requirements for refrigeration systems look, we can say, more or less in the same way. But there are countries like in the US and Canada who do not refer to the ISO standard. Looking into we can see in this EN 378 that is when safety valves are needed, and then we have a specific standard EN 13136, which is specifying in details how to size these valves. In the ISO standard, it's a little bit different, but to support, we can say, customers, we have our Cool Selector tool, where all these requirements are implemented, so we can easily select and make calculations, and we will come back to that in a minute. This is how it looks like right now, but as you can see now, we have already the next slide. In a couple of years, this European standard for safety valve will be converted into a ISO standard, so there will be one global standard for how to size safety valves. Yes.
Niels, I have one question here. In split AC, where are the pressure regulator located to protect the compressor?
To protect the the compressor is normally protected with a built-in safety valves in the compressor. That's a very typical one, but it could also be mounted externally. Yes, I think that was what. So then I will, if there's not more questions for now, then I will hand it back to Alejandro.
Thank you very much. Thank you very much, Niels. And following on this same, let's say, topic or part that you were discussing before we jump into the standard and to the maximum PS of a system. That's where I want to go on the next slide. This is, guys, what I'm showing now on the screen, the way that a safety valve should work according to the standards and to the requirements that Niels was already mentioning us. This is, as Niels said, your last line of defense in your system when it comes to having pressure that is getting close or that is reaching the maximum pressure, the PS, your system pressure design that you have on your installation. Now, how that works, let's say, let's take it step by step. We have a working pressure, yeah, and that is the pressure that your system should be working under standard conditions, yeah. And related to that, somewhere around here, you will have as well, you know, a maximum working pressure. Yeah, it can vary, but it will do that only within certain limits. Once the pressure in your system goes higher than what it should be working on, yeah, once that for some reason the pressure starts to increase and the system is not able to control that and regulate that pressure, before we get to the use of a safety valve, in between this working pressure and the set pressure of our safety valves, we will have some other type of safety devices as well. One of them would be, for instance, a pressure switch, yeah, also called a high pressure cutout, which is basically a switch that is measuring the pressure, and when it gets above certain level, above certain limit, then it will shut down your compressor to make sure that it doesn't continue building up more pressure. However, if that fails, or if we have a pressure increase due to some other reason rather than the compressor, the one responsible for guaranteeing safety here and for guaranteeing that the pressure is not going to go more than 10% above your PS, that is your safety valve. Yeah, that is the safety valve that you need to have, protecting the different vessels, the different part of the systems, depending on the specific system that we are talking about here. And the way that it works is that all safety valves have a set pressure, and that set pressure means that they have been calibrated to open at that given set pressure. Yeah, the requirement tell us that once the set pressure is reached, the safety valve has to open. Yeah, and it has to be fully open before we reach 10% above that set pressure. Now, on this case, we are talking about the Danfoss safety valves for this example, and for that reason, you can see that the valve has this black line, meaning that our safety valves will be open before they reach that 10%. That is, of course, within, as you can see, within the requirement, but it as well help us to guarantee that you're going to be blowing all this excess pressure, as soon as it reaches the pressure setting. Now, once the valve has opened, of course, this is relieving pressure, and that means that the pressure in our system should be going down. Now, a very important part, as you can already imagine here, is that you have a system that is blowing our, in this case, refrigerant to the environment. Yeah, and for that reason, another very important part of a safety valve is that after relieving the pressure, it should close. Yeah. Now,
Alejandro, I have a question,
yes,
a little bit related,
sure,
I think, from Mutasim. What usually cause high-low pressure switches not functioning over time?
Well, when I said, when I mentioned on that end, high pressure cutouts or high pressure switches are safety devices, and they should be tested according to regulations within, defined periods of, of time. Yeah, and from that perspective, we wouldn't expect, or we shouldn't expect them to fail, or at least if they have some issue, or if they are miscalibrated, for instance, we will expect to catch that in a reasonable, period of time. Yeah. So from that perspective, I think that kind of risk should be addressed following the requirements for testing, for validation, and for maintenance of such high pressure switches. Yeah, but there are other reasons that can increase the pressure, yeah, in a system aside from from the compressor itself, yeah, like refrigerant expanding due to high temperatures, and those kind of things. And in those cases, even our high pressure switch is properly working, that will not prevent the increase of pressure. And it is especially in those cases where safety valves become even more relevant. Yeah. I hope I answered the question on that.
Thanks, Alejandro.
Yeah. Then let me get back to the presentation. As I was saying, the important part, or the second important part of safety valve after opening, is that it needs to close. Yeah, and it needs to close, as I said, because it is relieving pressure, and it is relieving refrigerant, which, depending on which we are talking about, it's going to have a cost, and it's probably going to have an impact as well. And here we have two different cases. Yeah, on the left side, I have been talking about our Danfoss safety valves, and the fact that they will close before the pressure reaches 10% below the set pressure. Yeah. However, you will find as well some other safety valves which the resetting pressure will be all the way up to minus 15% or 15% below the set pressure. Yeah. So this means that you will actually blow or release more pressure and more refrigerant in this case before the valve is fully closed. Now, if we talk about the regulations and the requirements that Niels was mentioning in the previous slide, the minus 15% will be as well within the limits or within the regulations in general of the PED. Yeah. However, there are some other industry standards that are a little bit more strict on this end, and that require what we have on the left, which is the the 10%. This makes a relevant difference, as you can see, not just in the amount of refrigerant, in the amount of pressure and the time that the valve will be open when comparing the 10% to the 15%, but as well, it makes a difference on where your let's call it your PS, your pressure design is for the system. And that is because you need to have a difference, and let's call it a space between your working pressure, yeah, and the point where the valve is going to close again. And that is because in between these two, as I mentioned already, you need to have your pressure switch, but as well, that is because you don't want your safety valve to be opening and closing during, let's say, regular operation, or where the pressure is slightly above the working pressure. Yeah, the safety valve is intended to operate only in the case, let's say, of an emergency, when the pressure is going really, really high and getting close to your limit. Yeah. So from that perspective, I've mentioned here already a couple points that are key to remember. The 10% plus that all safety valves have to open. They all have to be fully open before they reach 10% above the set pressure. The resetting pressure, yeah, which, as I said, can be all the way up to 15% according to the regulations we have been discussing. But if that can be let's say lower, as in this case with a minus 10%, that will bring benefits in the amount of refrigerant that is lost in the case of an event, in the time that the valve is going to be open, but as well when it comes to design. yeah, to the design of your system and the maximum pressure that all the components have to be rated for in this case. And once we are talking safety valves, this is, let's put it this way, general operation of a safety valve. Yeah, it needs to have a set pressure, it needs to open, and it needs to close. Yeah, and that should be similar for all safety valves. But there are other particular things or particular characteristics of safety valves that are quite important to be aware of. Yeah? And as well, it's quite important to take those in consideration when we are, let's say, deciding or designing our system. Yeah, and that is because that will have an impact, a very relevant impact in how our system is going to perform related to safety valves. So as I said, in addition to this closing or reseating tolerances, we will have as well different sealing methods. Yeah, and that will have an impact on how the valve is going to perform. Just to give an example on one difference that you can have. On safety valves, you can have hard sealings or you can have soft sealings. Yeah, hard sealings are, let's say, very robust, but it's very often that they are not bubble tight. Yeah. On the other hand, soft sealings are usually bubble tight if they are made correctly, but they are sensitive to the type of refrigerant, to the type of oils that you have, and as well to aging and temperatures and opening. So we have to take these things in consideration depending of the system that we are talking. In general, when we are talking refrigeration and the common refrigerants, we will decide or prefer a valve that is gas tight on this end, so we don't lose refrigerant over time. Yeah, so from that perspective, talking about the optimal safety valves when it comes to these topics that I was mentioning, it's a safety valve that is tight, yeah, and that it will remain tight for its lifetime, meaning that unless it is required to open because of of an event of let's say pressure rising above what it should be, the valve should not leak and it should remain tight and not allow any refrigerant to go out to the environment. That is one critical point. Then a second one is the set pressure. Yeah, the one we have been discussing as the point where the valves start to open, that should remain unchanged for the lifetime of the safety valve. The valves are calibrated, let's say, when we before we install them, before we get them. But of course, we have to guarantee that that set pressure is going to stay. Yeah, and it's going to remain unchanged for the lifetime, and that has to do with the design of the safety valve. And then coming back again to the same topic of the closing tolerance and the reseating pressure, that is as well very important point, especially for high set pressures. We want the valve to close as soon as possible once it has opened, so we can reduce our refrigerant loss on this case. Anders, do we have a
we have a question from
here?
Irshad. Yes, for air-cooled chillers, what type of maintenance work can we do on safety valve and on what frequency?
Well, I would say that here the requirement when it comes to to safety valves will be similar for for different type of refrigerant systems. There is depending on the country, usually a requirement on how frequent safety valves has to be on one end inspected, and on how frequent safety valves need to be calibrated. Yeah, in general, that requirement will never exceed or will not exceed 5-year period of time. Yeah. So from that perspective, at minimum, safety valves should be calibrated within 5 years. However, we know that the requirements depend on the specific country, on the specific region, and we do have requirements in some countries where safety valve have to be calibrated each year. Yeah. So to fully answer that question, the proper answer would be that we need to look at the local regulations when it comes to pressurize systems, to see how frequently is that we need to to do a calibration on the safety valve. And if there is nothing on that end, then the minimum will be each 5 years for all safety valves.
Thank you, Alejandro. Just one more question here from Muhammed.
Sure.
Is it sufficient just to choose a standard type approved safety valve?
Well, that's actually a very relevant question, because there is a lot behind this one. The answer is no. We have to take consideration what the safety valve is going to be used for. Yeah, and what is that we are protecting? What is the capacity needed? And then based on all those factors, is that we will choose, safety valve that will function according to the requirements of the system that we are protecting. In a few more minutes later on the discussion, we have some more information. Neil is going to walk us through some of the let's say consideration that had to be taken when selecting a safety valve. But it's very important to remember that let's say it has to be fit for purpose, and the safety valve that we are going to choose and install in our system has to be selected and considered to do the job that we require the safety valve to do here. Yeah.
But you could also say that there are many safety valves on the market, but what is important is that you choose a type approved safety valve. The type approval, we can say, will guarantee that the valve is operating as it is specified in the standard. But these type approval safety valve can be used for many different purposes. So as Alejandro mentioned about the sealing material for particularly for refrigeration industry, also has to be taken into consideration. So there is a lot of things. That is all everything about the safety valve. As Alejandro mentioned, it has to be fit for the purpose. But later on here, we will also look into, it's not just, we can say, to choose a safety valve, but it is also how it has to be installed. But we will come back to that.
Just one more question here. I think we have touched upon it, but Suran here asks, how often do valves need to be calibrated?
Yeah, but again, this is something that we can come up with recommendations. And as Alejandro mentioned, 5 years, that is the maximum that we go out and state for our product. But that is really where the local authority are the one who decide which interval that has to be followed. The standard we have been looking into come with some recommendation, but local requirement, that is, we can say, the law also here. But generally, you can say you should check your safety valve that it is not leaking. That you probably should do even often than once a year, because if your safety valve is leaking for one reason or another, then you are losing your refrigerant.
Thanks, Niels.
Thank you, Niels. And then, coming back to the specifics of safety valve characteristics and how do they perform according to the different type of sealings. We have some details on our newest product when it comes to the safety valves portfolio, and that is our safety valve SFA10 and SFA10H. This is a safety valve that was released last year to the market, is extending our portfolio of safety valves when it comes to capacities and when it comes to pressure settings. As well, it is designed to to meet the standards that we have discussed, plus some other industry standard that are a little bit more strict that the general standards. One thing that I like to highlight here, it's the sealing material. Yeah, and as I previously mentioned, we have different type of sealings, and that will impact in the fact if the valve is gas tight or not. Yeah, and in this case, our safety valves, the two variants that we have, and I'll get to the variants in a minute. Both of them are gas tight, and both of the type of sealings that we have are soft sealings, and that is because when we have a refrigeration system, we don't want to lose any refrigerant under normal conditions. Yeah, and that's why we have to look for this characteristic on this type of safety valves. On this case, you can see that we have one variant which we call the SFA10 with a chloroprene sealing material, and then we have a different variant, so-called 10H, on a different sealing material, which is EPDM in this case. And this one here on the right, the SFA10H, it's dedicated and intended for CO2 refrigerant. That is as well reflected when you see on the pressure settings of the valve. The SFA10 can go from pressure settings 10 to 27 bars, and then the SFA10H can go from 28 to 65 bars, which is a range that is more common on CO2 system, at least on the subcritical part. The reason we have to select or to split in this case onto different two sealings is exactly to reach this characteristic here. The fact that the sealing is gas tight, that it will not release refrigerant, but to guarantee that when the set pressure is reached, it's going to open and it's going to operate within the requirements that we have discussed. Be fully open before 10% and be, in this case, fully closed for our safety valves below the 10% minimum reseating pressure. Yeah, and that is, as I said, one thing that we should take in consideration when looking at a safety valve. It is especially critical or important when we go to high pressure settings. Yeah, that kind of characteristic, but it's something that we should keep in mind. And here, on this case, the design of this safety valve has been made taking in consideration the fact that we want it to be gas tight, that we wanted to keep the same pressure setting, at close its lifetime, and guarantee that when it will be required to open, it's going to do it within the the limits that are required. Yeah, so you can get a type approved safety valve on this end.
Alejandro, just a question here.
Yes.
From Mikhail. Can safety valves just be installed globally?
Well, no. If the question is in relation to the type approval of the safety valve and the requirements in different countries, the answer to that will be no. Niels already mentioned when talking about requirements and regulations that in the particular case of the United States and Canada, we have some particular and local requirements and standards that have to be fulfilled. So from that perspective, a safety valve that is type approved, let's say according to European regulations, or according to the ISO standard, doesn't fulfill just by that. Yeah, it doesn't fulfill just by that the requirements of the US and Canada. And here, being very specific, for the US and Canada, the safety valve will be required to have a what it's called an MB mark, the national board mark, which will require the safety valve to be designed and tested according to the ASME standard. Yeah. So from that perspective, when talking about installing safety valves globally, we should be aware of the local requirements that we have for different countries. In general, what we see in the market is that United States and Canada have these particular requirements when it comes to this mark, and safety valves have to be, let's say, marked according to that. So not all global safety valves can be used. In other countries, the experience is that yes, they can be used almost in all countries, but we have always to be aware of the local requirements that we might have.
Okay, super. Thank you. Another question here from Carlos. You mentioned 10% blowdown closing tolerance. What do we see in the market in general?
Yeah, and here we see a mix. Yeah, as I mentioned, we see some manufacturers sticking to this minus 10%, but we see as well some others on a minus 15%, which has these impacts that I previously mentioned. Yeah, if we go outside of the European regulations, and then I'm talking on that specific regulation that I was mentioning for the US and Canada, then we can have even lower or bigger blowdowns. Yeah, there is no specific requirement. There is no this minus 15% requirement in the ASME standard. So you can have safety valves in those regions that will have blowdowns higher than that minus 15 for 10. But for the European and ISO standard as well, which is global, and I think this will be a common practice, we will see somewhere between minus 15% and minus 10% for some brands like Danfoss, where we stick to some more strict regulations or standards. Yeah.
Okay, thank you very much. It's so great to see all these questions coming in. So just taking another one while we're here from Ramesh. What is the relationship between design pressure, actual operating pressure, and safety valve set pressure?
Maybe Alejandro, you should go back to the previous
yes.
slide.
I'm going back to the previous slide, Niels, and if you can take this one, that'll be great. There you go.
Yeah. Well, if you look at these figures here, you can say then you have the working pressure, and you have the set pressure. Depending on which type of safety valve you are choosing, you need to consider the distance between the set pressure and the working pressure. If you have a valve with a closing tolerance of 15%, you generally need to, we can say, have a higher design pressure of the system, because you don't want your safety valve to blow. Whereas if you choose the one in the left side with the 10%, you can narrow the distance between the working pressure and the set pressure down, and in this case here there is a difference on 5%, and 5% doesn't seem from a lot from we can say at low pressure, but if you are thinking about transcritical CO2, then it is really a big difference. If you take a safety valve with a 10% closing tolerance, then a rule of thumb state that 20% difference between the normal working pressure and the set pressure, that is a good choice. Then you have sufficient room for your pressure cutoff, safety cutoff as a pressure switch. So you will not get in to any conflict with that and with the opening of the safety valve. If you are going for one with a closing tolerance of 15, you probably need to increase the 20% to 25%. I don't know if that was the answer on the question.
Otherwise, you are free to ask more questions. There's one more here from Christian. Minimum reseating pressure percentage. Does the valve first close when the pressure is lower than the -10 of pressure setting?
No, it closes. We can say that depends a little bit of the design, but it closes gradually. But you can say when you state in your for your product that you guarantee that the valve is reseated within 10%, then it has to be reseated when the pressure is 10% below. But it is okay if it is reseated within 5%. So that's we can say that is an advantage. So these 10% below, that is the maximum, and again, as also for the opening pressure, the 10% above when it is opening, that is also maximum. So if the safety valve can open within 5%, that is also okay.
Thanks, Niels. There's one here from Babak. Set pressure for transcritical CO2. Where to install safety valve to prohibit dry ice formation during discharge?
Yes, dry ice in a CO2 system, that is something to consider. If you are working with a CO2 system and you are expanding in the gas phase, then normally this is not a big issue. The normal way to install the safety valve to protect a vessel or compressor, that is always in the gas phase. And there you can blow the gas to the atmosphere as below the critical point. I don't know if everybody is aware of that. The situation with CO2 as a refrigerant is very special, because when you are blowing to the atmosphere with CO2, then you are going below the triple point of CO2. So there will be no liquid, or liquid cannot be present at below this point. So then it become solid. And then you can, when you are expanding, then you can generate dry ice at the outlet of the safety valve. So on the gas phase, which is the normal way to install safety valve, you have to consider the formation of dry ice, but that is, you can say, to make your piping, so the outlet pipe for your safety valve, as simple and short as possible, then there should be no problem. The big problem with CO2 and the risk of blocking the outlet, that is where it is a safety valve installed in a liquid line, and that is not very common to use. That is only in the case where you have to protect against trapped liquid, and the recommendation is there to blow not to the atmosphere but to a pressure above the triple point. Then you can remove this risk.
Thank you, Niels. And
Thank you,
again,
Niels.
just feel free to ask questions. It's super great. They keep coming up, and just continue to fire away at us. So super.
Coming back to the details where we were seeing on this particular safety valve. As I mentioned, there is different standards, that we can follow. On this case, it is mandatory to have a CE approval, and that is to fulfill the requirements of the standards that Niels mentioned. But as well, we can have approval according to some other industry standard, like it is TUV, for example, and in this case, our safety valve has as well a type approval by TUV. And one of the particular things of that is that the minimum reseating pressure of the safety valve is going to be that 10%, which means, as mentioned previously, that the valve is going to be closed when it's guaranteed to be closed by the time that the pressure is 10% below the pressure setting of the valve. For this particular safety valve, for the 10 and the 10H, we do have two different variants when it comes to connections. As you can see on the left, we have a set of variants with the straight threads or G threads, as they are commonly called, as well. And then we have as well a set of variants with the tapper threads or so-called NPT threads. And this is our way of approaching different type of installations, different type of requirements, and making sure that it is as easy as possible for customers to install and to integrate the safety valves into their systems. And now, another product that is very related to a safety valve and that we haven't discussed so far is a changeover valve. Yeah, and for the one, yeah.
I'm just gonna interrupt you because we have two questions now. One of them is about what you're gonna speak about in 2 seconds. But let's take the first one then, and then you can get back to the to what's come up next. We have Georgie who asks, if liquid phase enters and the valve opens, what will happen to the safety valve?
The safety valve will opens up as if it was a gas. Well, as a safety valve, the safety valve we are offering is designed for as a gas safety valve, and type approved according to these requirements. You could also have it approved for liquid phase, but that's normally not required for refrigerant system. But if you have, we can say, a situation where you have liquid, then the safety valve will just operate as it was a gas. The capacity would be much higher because the mass flow is much higher. So in principle, it works also on liquid.
Thank you, Niels. Then, as I said before, Alejandro, the next question I think is a good opener for what you're going to speak about in 2 seconds. So from Irshad, the question here is, once we remove the safety valve for calibration, can we run the unit with a single safety valve?
Well, and before answering directly on that, yeah, we are going to look at the changeover valve, because probably this is going to answer part of that question. Yeah, as I was saying, one part that we haven't discussed yet on the topic is the use of changeover valves, and the fact that commonly safety valves are installed in this type of double arrangement. And for the ones that are not really familiar with a changeover valve, the function of this valve, this is a three-way valve. It has an inlet, yeah, and this is what is connected to your system, yeah, to your vessel, to the part of the system that you are protecting. And then you have two outlets where you need to install a safety valve on each of these outlets. Yeah, the reason that you are doing that, and the reason you need this type of three-way valve, is that with the spindle that you have here, you can control which of these two outlets it's open. Yeah, and the intention here is that you will have your safety valve, one safety valve that is protecting your system, meaning that this changeover valve will be open to one of the ports. Yeah, That will be the valve that is protecting the system. And then you have as well a backup safety valve on the other port, as it is shown here on the right. And that means that, for example, in the case that you have an event, yeah, and it opens, or that the valve has reached the time and it requires to have calibration, yeah, what you can do is you can change this changeover valve to your backup safety valve, or to your second safety valve, yeah, to be protected by that one, yeah, and then remove your safety valve that needs calibration, that needs service. Usually, depending on the case, you will blind plug this connection here while you take your safety valve for service. But at all times, your system will still be protected, yeah, by the other safety valve that you have here. Now, in order to remove the other safety valve, or to service to that one, you need to have the other one back, for sure. Yeah, and as a practice, a better practice here is that once you take one valve for service, you will replace it by another one. Yeah, so you will not leave your system, let's say, only with one safety valve, but as well, this will bring benefits in the way that you don't have to visit the same installation twice. Yeah, once for moving and then for placing it back. You can simply change the safety valve by another one, and then by those means cover the service or the maintenance requirements of the safety valves. And here, a little bit back to you, the question, Niels: is there any restriction or requirement against leaving your dual safety valve arrangement only with one safety valve while you are giving service and maintenance to it?
No, no. The most important thing is that when you are sizing the safety valve, then you are sizing each safety valve so it has the full capacity. That means that you just need to have one safety valve in operation. So you can just take the other one off and make a service on that one. So that there are no requirements for, we can say, how long time that must take or anything. The only thing that you need to be careful is that when you remove a safety valve, then you need to we can say plug the connection to the discharge pipe. So in the event that the other safety valve is operating, so the gas is not blowing into the room where the safety valves are installed.
Oh yeah,
Thank you,
very
guys.
relevant
One more
point.
question from James. How many relief valves can you pipe into a common vent line? Should that be sized to one valve or all valves to the open?
Yeah, I would like to wait a few minutes to answer that one, and then continue to the next point.
Yeah, just before you do that, I just want to say, remember that we have this survey. There's a link in the chat, and please, we would really appreciate if you take the survey at your leisure when it suits you guys. But I just wanted to let you know that it would be really appreciate if you do it. So see if you have time. Thank you, and then back to you, Niels.
Thank you. Okay. Well, one of the things is that we have been talking about now, that is the safety valve, the special things about the requirements, and there's a lot of requirements that we have to think about when we are selecting safety valves, and that can be a bit complicated. But we have tried to come up with a tool which is a part of the Cool Selector, and I hope that all of you know our Cool Selector software. Cool Selector software is, you can say, as the name states, it can do a number of different things. It can select products. It can also make a calculation. It can also calculate some requirements. So it is a kind of a design tool for you. And finally, you can use that for documentation. But I'll try to show you a couple of examples here. So Alejandro, if you are or you already have it, can we get Kurzeletter highlighted or the screen? Yes, no, not that one.
The presentation, yes.
Presentation.
If we can go to the presentation.
Yes,
There we
we
go.
are. There we are. Well, this is a screenshot of Kurzeletter just to make it, we can say, a bit easier to look at. In this case here, we have different possibilities in Kurzeletter. First of all, we can choose which standard we want to use when we are making a calculation. In this case here, it is the European set of regulation, which is also the most common one. And here we have chosen to focus on, we can say, the required mass flow. So in this case here, if the designer of the system know how much capacity he needs, then it's really easy to use Kurzeletter here to select the product. So he just need to, we can say, make 3 clicks. First of all, that it is a mass flow. Then he need to state the required mass flow, and then he need to specify the set pressure of the valve, and then he will get the result. So it is really easy to do. No need to look into any tables. But we can say that is with focus on the safety valve alone. But that's not, we can say, what is needed in the system. We also need to look into the requirements of the pressure drop in the inlet line and the pressure drop in the outlet line. And there we can also use Kurzeletter. So if we're going to the next slide. So that's you, Alejandro, who changed, I believe. There we are. So here we have put a couple of, we have selected to calculate the pressure drop in the inlet line and the pressure drop in the outlet line. And starting with the inlet line, normally if we have a safety valve and we mount that on a vessel, then this line is not very long, maybe half a meter. So we can specify exactly how our design is. And then Kurzeletter will then calculate the pressure drop in the piping and the changeover valve. And then it will check if this pressure drop is within the tolerances or the acceptable limit. And this limit is a pressure drop of 3% of the set pressure. This is quite important that we check this pressure drop in the inlet line. If we took an example and we made a pipe on 10 meter at the inlet, well, when the pressure goes up, then the pressure in the vessel where it was mounted will be the same as the pressure at the inlet for the safety valve. But as soon the safety valve opens up and we generate a big pressure drop there, then the safety valve will feel that the pressure is dropping in front of the safety valve, and then it will close again. Meaning that if the pressure drop is too high, then the safety valves will start to hunt, open and close, open and close. And I can tell you, if that happens with a very high pressure, you can absolutely hear that and you can destroy a lot of things. So that is not okay. And that's the reason why this is put in as a requirement in the standard. And you can very easily calculate that with Kurzeletter. On the outlet, it's a bit of the same. There we also need to check the pressure drop in the outlet line. We can build up our outlet line exactly as we want to design it. Then Kurzeletter will calculate the pressure drop. And we will verify if the pressure drop is within the limit. The normal this limit is 10% for all. It is 10% for all standard safety valve. But there is one thing more that we need to check. That is the sonic velocity in the outlet pipe. So think about that. We are working with a high pressure. We are expanding through the safety valve, and then we are going out into the atmosphere, and the velocity are increasing a lot. So we can easily reach sonic velocity or the speed of sound. And the speed of sound, that is the maximum velocity that we can reach in a normal pipe. So if we are about that level, we need to increase the diameter of our outlet line. But all these things, Cool take care of that. So that is really easy and time saving to use that tool.
Yeah, and also it's free. So, and we have posted the download link in the chat. So visit our download page on our website and download Cool Selector for free.
Yeah. If we're going back, then we take the next slide. Yes. That's, I would say the first one, that was a simple selection. Number two, that was a common selection. And then number three, that is a complex selection. And that was also referring to the question which was raised earlier. And one of the part of the question was, how many valves can we connect to a manifold and have one outlet line here? On this example here, we have put three different safety valves, connected them into a common outlet line. And all these things you can do in Cool Selector and calculate the pressure drop. If you think about doing such a design and do this pressure drop calculation, checking for sonic velocity and all these things by hand or in an Excel tool, I can guarantee you that this is some work to do, and it will take, with three safety valves, you will definitely spend more than 1 hour to do that. But here you can do that within a couple of minutes. The question was then raised, how many can we combine? I think the question is, there is no maximum limit in principle, but I think you need to consider what is practical. But having a number of safety valves, it could be a bit complicated to have that vent line or outlet line going out from each safety valve, so it makes sense to put a number together. But I would say, from a practical reason, you should not put too many together, because there are more things that you need to consider. As a base, you should consider the safety valve protecting against the same issue can blow at the same time, meaning that the common outlet line should then be designed in a way that it can take the full capacity, and then it becomes big. There could be some cases where you could say it can never ever open at the same time, but that has to be based on a risk assessment. So my best recommendation is that if you have valves protecting the same kind of, for the same thing, you could put some valves together. I would not personally go for more than maybe between 3 or 5. Then if you go higher, then it will start to be a bit complicated. Also, if one of the valves start to leaks, and to find which valve is leaking, it becomes a bit more complicated to find that one. So, but theoretically, you can do it. And so, with all this, we can say selection, calculation. That is a part of your documentation when you're making system. So you need to add that to your project to document that the safety valve has been selected correctly. And you can also use Cool Selector for that. So if you are going back to the next slide and showing the reporting part of Cool Selector, the Cool Selector, when you make the different calculation, then you can just print that out in a report. You can print it out for a printer. You can have that on a PDF or whatever you like. And this documentation, that is all what is needed as documentation for the authorities. And that is the documentation for the safety valve, the changeover valve, and the up and downstream or in or outlet pipes. So everything. So that is really where you can get a big benefit of Cool Selector.
Thank you, Niels. It's time for us to do the wrap up now. I just want to mention again the survey we have. It's only 1 or 2 minutes for you to, if you would like to fill it out for us and help us become better. I would also like to mention the tip sheet we have put together. I think there should be a link now, and there is some where we have put together some of the things we talked about today in a graphical way, how to select a safety valve, what to consider when selecting a safety valve. I will also take the time to say thank you to Alejandro and Niels for your presentation. And most important, it's been a pleasure to be with all you guys out there. So happy you've been here and tuned in to listen to us and asking us all those really good questions. So it's been an absolute pleasure to having you and have this conversation with you guys going on. It's been super great. If there's any questions we have missed, we will look through the chat, of course, and make sure that we get back to you as soon as possible with any questions we might have missed or come in very late. So yeah, so that's actually last thing of the day. Yeah, so thank you everybody for listening in, and thank you Niels and Alejandro for doing the presentation for us. And watch out for more stuff from us. And we also have Danfoss Learning, of course, where you can go in and have and get training on Cool Selector and other great stuff. But we'll be back, and hopefully we'll see most of you, or all of you guys, next time. So thank you very much.